Our project is all about detecting whether a piece of text was written by a human or generated by AI. Next. So, why it matters? It raises problems such as misinformation, academic dishonesty, and content authenticity. That's why our project is important. Next slide. For this, we used a big data set and for efficiency, we reduced it to 100,000. Each text sample was labeled 0 for human and 1 for AI. We split this into training, validation, and test areas. Next slide. For pre-processing, we use the BERT tokenizer from Hugging Face to break down the text, applied padding and renamed columns for consistency. We also used a data collaborator. Next slide. For the model, we built on top of BERT-based uncased. Instead of training everything from scratch, we fine-tuned only the top pooling layers while freezing the rest of the parameters. This makes training more efficient while still learning the features needed for our classification task. To train and evaluate the model, we use the Hugging Face Trainer API. Over to you, Tashara.
For our training setup, with a batch size of 16, and most importantly, we added early stopping to avoid overfitting and TensorBoard login to track progress effectively. Moving to next slide. For evaluation, we focused on accuracy, AUC, ROC score, and F1 score, the right choice for a binary classification problem with some class imbalance. Accuracy gives overall correctness, AUC shows true predictive power, and F1 balances precision and recall. Moving to the next slide. On the final test set, we achieved 91.5% accuracy and AUC of 0.972 and an F1 score of 0.915. Training and validation losses were stable, confirming good convergence. Moving to the next slide. During training, the model improved steadily. By step 2000, accuracy was 87.3%. At step 5000, it reached 89.8% and finally stabilized at 91.5%. Early stopping ensured performance did not degrade. Overall, the model showed strong, consistent learning and excellent generalization. Over to you, Rishita.
Yeah. Our main challenges was the overfitting because in here first we test distilled bird and bird for our model. First we train distilled bird uncased model with feature-based fine-tuning. Or in here we saw the validation loss was increasing. Also, the gap between training loss and validation loss is the very high. Therefore, this is the huge sign of overfitting. Then we test distilled model again with full fine tuning. In here, first two epoch is give good performance, but after the third epoch, it shows validation loss was increased hugely. Also, the finally we can see huge gap between validation loss and training loss. Also, this is the huge sign of overfitting. Therefore, we decide to test the uh, bird based model, bird based uncased model. In here, we can see this training loss and validation loss converge gradually. Also, there are no overfitting sign. We can see the gap between training and validation loss are very small. Therefore, there are no sign to overfitting. Then we choose this model as a model, and this is the final result of our model. Then I will hand over to Chelana to conclude this.
We'll talk about our key limitations and lessons learned throughout our project. First, building this model was resource intensive. It took us many tries to get it right, as you can see in previous slides. Each test needed a lot of computer power and time. Our final model has a very good accuracy of 91.5%. Another version had 96.5%, but it was unstable. We chose a stable and reliable model over a slightly higher but unstable number. We believe a model you can trust is more important. Finally, there are some inherent challenges. Our model struggles with very short text because there are fewer clues. It also finds it hard to detect text that is written partially by human and partially by AI. And finally, as AI technology itself gets better, our model will also need to keep improving. So, what's next? Moving on to the next slide. For the future, we want to train the model on other languages, not just English. We can combine different techniques to make it even stronger. We can also customize it for specific needs like checking university essays. And our goal is to turn it into a real time tool that anyone can use online. Moving on to the next slide. To summarize our project, we tackled a very important modern problem, telling human and AI text apart. We used powerful tools from Hugging Face and the BERT model. We focused on building a solid and trustworthy system. We achieved a high accuracy and high F1 score. So finally, our project is about building a bridge to a future where human and AI can collaborate with clarity and trust. Thank you.